All right, guys. So we're gonna start this module 5 review. Before we start that, I wanted to go through some quick announcements for you guys. All right, so here they are. First one, November 29th is gonna be the last day for any makeup work. So if you have to do any of the learning units from modules 4 through 6, you have the time to make those up now. You cannot go back after that fact and make up any of those assignments. They will not be included as part of your grade. Assessments are not included. So the end of module assessments will not be included in that. Only the learning units from modules 4 through 6. So again, those are 50% of your grade. Um, Free points. So if you get anything less than 100% on any of those, then obviously your grade is going to go down. So just be aware of that. And make sure you guys go back and make those up. And again, that needs to be done by the 29th. The 29th, that whole week is Thanksgiving break. So just make sure, not if you want to go back and do the work, you have that time to do the work then. If you were not present for your group's collaboration, then just go back into it and start your own collaboration session and do the work on your own. You'll be marked present for the actual collaboration, and you're okay. All right. June 6th is a Sunday evening, and that will be the last set of learning units you need to turn in. So 7.3 to 7.4, those will be due that night. After that, and that morning, the final exam review is going to be posted. So the final exam is going to be, we're going to cover everything that we've learned in the class. All right. And actually, I'll talk about that in a second. Okay, so, and that can be turned in for extra credit as long as you turn it in at the latest by December 13th uh, at 11:59 p.m. Okay. Then you're good to go for that. As long as you turn that in, you'll get the extra credit. The final exam is going to start December 14th through the 16th. So you'll have roughly 3 days to complete the final exam. So it's going to be posted at 8 a.m. December 14th. Then it's going to close at 11:59 December 16th. All right. The final exam, so it's a cumulative exam. I forgot how to spell cumulative. Whatever, I'm not even gonna write it. Okay, so the final exam is going to be cumulative, meaning it's going to cover everything that we've covered in the class. So the final covers module 1 through 7. Okay. Um, what you'll need to know, it's going to be not two parts per se, but there'll be both multiple choice. There'll be fill in the blank. And short answer. Okay. So my suggestions for you, if you're going to start studying now, is just to start reviewing all your old work that you've done, and then use that as your review. You also have the study guides that I passed out, or the review guides that I passed out, so you can work on those as part of your final exam review. So those are the things that I would worry about for the final. I don't remember how many questions it is, but I believe it's something like 46 questions. All right, so just be aware. All right, so let's get started on this review. Excuse me. Okay, so number one, so let's see, let's skip down to the end. So we want to determine a 90% confidence interval for the difference between the proportion of girls age 13 who are unhappy with their bodies, and the proportion of girls age 18 who are unhappy with their bodies. All right, so the first thing we want to do, we know it's going to be a confidence interval, is set up our 4 boxes. All right. Once we have our 4 boxes, we obviously have 2 different proportions. So we have a proportion of girls age 13 who are unhappy, and then we have a proportion of girls age 18 who are unhappy. So your P sub 1 is going to be girls age 13, and P sub 2 is going to be girls aged 18. All right, so you're going to have 2 different categories, let's say, right, or proportions. Okay, so what we want to do here, let's start collecting all of our information. All right, so we have that. So we need our x sub 1, n sub 1, p hat of 1. Then we have our x sub 2, n sub 2, p hat of 2. Okay. So what do we have? Let's find all this information. All right, so here it says we have a sample of 38 girls age 13. 20 of them were unhappy with their bodies, so 20 were not unhappy out of 38. We can divide those two. That will give us our p hat of 1. Okay, so now let's do the same thing with our age 18. So for the sample of 32 girls, 25 of them were unhappy with their bodies, so 25 unhappy out of 32. So that's that. All right, so now once we have that, we're going to start trying to find all of our important information. All right, so we need to find our critical value, which is the next step. So we need z sub c. Again, that's going to be based off of our confidence level. So we have that chart. I think it's from like 3.1 or something like that. Maybe 3.2. Yeah. So if it's a 90% confidence interval, then we use 1.645. So that's 1.645. So then our error is going to be your z sub c. I'm going to use the pink color for this. So your p hat of 1, 1 minus p hat of 1, divided by n sub 1 plus p hat of 2, 1 minus p hat of 2, divided by n sub 2. Okay, so I'm just going to plug everything in. So E is going to be 1.645 times the square root of, it's going to be 0.526, 1 minus 0.526 divided by 38 plus 0.781, 1 minus 0.781 over 32. All right, so you would just plug all that into your calculator, and that's going to be your margin of error, and that'll give you 0.179. Okay, so that's now our error. So what we're going to have to do for your confidence interval is you're going to take your p hat of 1 minus your p hat of 2. I'm going to put this in brackets, maybe. Minus e here, and then your p hat of 1 minus p hat of 2 plus e over here. Shouldn't do brackets. Let me just make it a different color. All right, so that's what's going to go in there. So it will look like this. So my p hat of 1, so it's going to be 0.526 minus 0.784, 1 minus e, which is 0.179, and then you have the same thing, so 0.526 minus 0.781 plus 0.179. Alright, so when we plug that in, that will get me negative 0.434 to negative 0.076. Alright, so that's going to be my confidence interval. Okay, so then a couple things you want to note for your conclusion. So say you have a confidence interval, and you have your interval, and you have a negative and a negative, then your p sub 1 is less than p sub 2. So the idea is what we're doing is we're taking p sub 1 minus p sub 2, and we're trying to figure out what the result is. So the result that we get from that is here and here. So either your answer is here or your answer is here. If both of those numbers are negative, then that means your p sub 2 is bigger than your p sub 1. That's supposed to be a 2. Alright, so if they're both positive, then p sub 1 is larger than p sub 2. Okay, so same idea. Now when you go to subtract it, if you get a bigger number, that means p sub 1, or a positive number. In order for that to be positive, p sub 1 has to be the larger of the two. Alright, so then the last one is if you have a negative and a positive, then you have a few options. The range is small. Actually, we'll say this. Then 0 is contained in the interval. So the difference is minimal, or cannot be determined. Okay, and then that's going to be the same for all of them. Okay, so then with this example, what do we say? So in this example, we have a negative and a negative. So because they're both negative, then we just look at our rules. Then that means that p sub 1 is less than p sub 2. So based on the results, girls age 13 are less likely to be happy with their bodies. girls aged 18. Okay. Okay, so that's the first one. So you can screenshot that. That's how you would do number one. All right, number two. Again, let's skip to the end. We want to data provides sufficient evidence at a .05 significance level to conclude that females are more likely than males to own cars at the state college. So it's going to be a hypothesis test because we're given a significance level. All right, so we have two different populations again, so let's assign them. So population one, are going to be the female students. Population two, going to be the male students. Okay, so now we need to figure out what our hypothesis is going to be. Remember, your null is always equal. So it's going to be that P sub 1 is equal to P sub 2. Your alternative is females are more likely than males. So it's going to be that P sub 1 is greater than P sub 2. Okay, so that's that. All right, next, let's find all our important information. So you have your x sub 1, n sub 1, p hat of 1. All right, and you're also going to need your p bar. These are all twos, sorry. All right, so your x sub 1s, you have 33 females, 42 males. 21 of the females had cars, 18 males. So let's divide that here. And that would give me 0.636. And here, 18 divided by 42, that'll give me 0.429. All right, then we need our P bar. So for your P bar, you're going to take your x's and add them. So 21 plus 18 over 33 plus 42. All right, so you plug that in your calculator. Just make sure when you plug this in your calculator that you put these in parentheses. All right, and then divide them. Okay. All right, so that will give me 0.520. Okay, so that's that. All right, so next thing we're gonna have to do is find your test statistic. All right, so it looks all tricky, but so here it is. So it's gonna be z is equal to your p hat of 1 minus your p hat of 2 divided by the square root of all this. So it's going to be your p bar 1 minus p bar over n sub 1, p bar, 1 minus p bar over n sub 2. Alright, so let's plug everything in. So it's going to be z equals 0.636 minus 0.429 divided by the square root of plus over 42. Alright, and that will give you 1.78. So now remember we have to find the p-value next. So far, here's what we have. Here, your z is 1.78. So we need to find this area here. So we need to find the p-value. So we need to find the probability that z is greater than 1.78. Alright, so again, that's the p-value. So we're going to go to Desmos. Alright, so we're going to go functions, distributions, normal distribution. Leave that because we made a z-score. That's not going to be our minimum. Alright, and that's your p-value. So 0.0375. Alright, so that's our p-value. Alright, so the next part is the same as normal, alright? So you're going to take that p-value, compare it to your significance level. 0.05 is greater, so because it's greater, that means you're going to, reject the null, support the alternative. So if we say that, we'd say, based on our results, females are more likely than males to own cars at the state gardens. Alright, so that is that question. And so there's a confidence interval with two different proportions. Okay, so we got two more. Okay, so now we have a random sample of 10 patients. Alright, what we want to do, data to provide sufficient evidence that 0.01 significance level to prove that the vitamin E treatment decreases the thickness of plaque in a cardiac. All right, so you have your before and after treatment. So what you have to do is find the difference and label that D. Okay, so you are trying to find the difference between each one of these values. So you're just going to go through and subtract them. All right, so when you subtract them, that'll be 60, that'll be 70, that'll be 850, that'll be 60, more negative 10, 50, 80, it's 20, 30, 50, 40. All right, so once you have all of these D's, you are going to then find the mean and the standard deviation of it, and then we can continue with the rest of the process. So we'll go, okay, so you would plug all this information in the calculator to get the mean of all the D, and that's going to give you 45, right? And again, you can plug in the calculator or you can do it in Desmos. We've gone over that a bunch of times, so I'm not really going to spend time doing that. All right, and the standard deviation of that is going to be 26.4, and then N is going to be equal to 10. All right. Okay, so now it's going to be a hypothesis test. So we make our boxes. All right, so in this box, again, assign your two populations. So we'll say now we're dealing with the mean. So mu sub 1 is going to be before. Mu sub 2 is going to be after. So your null is going to be that mu sub 1 is equal to mu sub 2. Oh, sorry, no. Your null is going to be that the mean of the difference is equal to 0. So that's the same. Then the idea here we want to prove that the vitamin E treatment decreases the thickness and the plaque of the heart. So if it decreases the thickness, that means that the plaque level would be higher before than it is after. So we'd want the mean of the differences to be greater than 0. Right. If it was less than 0, then that would make it negative, which would mean that the thickness afterwards is bigger than before. So that's that. Okay, so then we need all of our information. So we have the mean, and our mean is going to be 45. Standard deviation of that is going to be 26.4, and is going to be equal to 10. Okay. So we use all that to find our test statistic. So T is equal to the difference. Oh, let's write it out. So it'll be D divided by S over the square root of N. So that'll give you 45 divided by 26.4 over the square root of 10. When you plug that into your calculator, that will give you 5.42. Okay, so that's your T. Then we're going to need a p-value calculator. So what that would look like currently, have 5.42. So we're going to plug all that stuff in. Okay, so that's that. So we go functions. Now we have t-distribution, degrees of freedom. Find the cumulative. You have your minimum, 0.24. Sorry, we needed to put degrees of freedom. So our degrees of freedom is going to be 10 minus 1. 9. Alright, so that'll give me a p-value of 0.0002. Alright, so that gives us that. Then we take that number, so 0.0002, compare that to 0.01. 0.01 is greater. So again, we're going to reject the null, support the alternative. All right, so then we write our conclusion. So we know that this is incorrect. We're going to use this. So it's based on our results. The vitamin E treatment decreases the thickness of plaque in the carotid artery. Okay, so that's our process for that. All right, so last one. Okay, so for this last one, look at something real quick. One second, hold on a second. Okay, so here we go. My bad. Okay, so for number 4, we are going to do what? So it tells us we're going to determine a 90% confidence interval for the difference between men, for gay men and lesbians, the age they came out. So, okay, so now what do we need to do? So we need to start off by collecting all of our information, or we need to assign our two populations first. So we have Mia sub. Oh, you can't see that color. So sad. So Mia sub 1 is gonna be lesbians. Mia sub 2 is gonna be gay. All right, so collect all your information. X sub 1, X bar. Oh my goodness. S sub 1, and then N sub 1. Then you have X bar 2, S sub 2, N sub 2. Alright, so there's going to be 17.5, 4.5, and 40. X bar sub 2 is going to be 15. Then you have 3. Then you have 35. Again, that's just all based off the information that's given to us in the problem. Alright, once we have that, we need to find our margin of error. So our critical value for 90% is going to be 1.645. Your error is going to be 1.645 times. Actually, let me write it out first so you can see it, and then we'll do that. So E is going to be T sub C times the square root of S sub 1 squared over N sub 1, S sub 2 squared over N sub 2. So E is equal to 1.645 times the square root of 4.5 squared over 40 plus 3 squared over 35. So when you plug that into your calculator, that will give you 1.5. Alright, so now you're going to plug all that in. So we'll have x bar sub 1 minus x bar 2 minus e, and then it'll go to x bar sub 1 minus x bar sub 2 plus e. Alright, so let's plug everything in. Alright, so we're going to have x bar sub 1, so it'll be 17.5 minus 15 minus e, so that's 1.5. 17.5 minus 15 and plus 1.5. So that'll give you 1, 2, 4. Again, we're looking at those signs, right? So they're both positive. So that tells us that our second proportion, the proportion for gay men, is higher, first of all. So because that number, sorry. I said that wrong. So because that number is positive, not that one, this one is higher, all right? Because it's a positive number, my mistake. All right, so same idea as we followed for the last example, right? If, let me see, this first example. So it's all dependent on this, what our signs look like. So in this case, they were both positive, so your first proportion is going to be larger than your second. Only difference in this one is that we're dealing with the mean instead of proportions. So it means that mu sub 1 is greater than mu sub 2. So what we'd say is based on our results. Lesbians on average come out 1 to 4 years later than gay men. Alright, and so that is your confidence interval for for means, for two different means. Alright. Okay guys, so that's the end of this review. Remember those announcements. Let me scroll back up to those announcements. Again, I'll probably send out a post later on, but this is just so everybody has it. And then if you watch this video to the end, I want you to, for extra credit, and don't tell anybody, it's just for the people who actually watch this, this extra credit. You're going to send me an email. RCC. Actually, no, don't send it there. Email in Canvas. Okay. Then subject is blank. Actually, we're going to do this. Subject is going to be you ugly. And then the message is going to be an emoji. Let me see how I get that in there. It's going to be this one. It'll be this one. I got to make one look like me. Alright. Oh shoot, I'm messing up. Let's get rid of this keyboard. Alright, so then that's going to be your message is going to be that emoji. And that's it. Alright, so you're going to send me a message, email in Canvas, only on Canvas. If you send it to my regular email, then I'm not going to answer it. So it's going to be email in your Canvas shell only. The subject should be you ugly. and then you're gonna have that emoji as your message. Okay? It doesn't have to be that one. You can choose a emoji that represents you. But it just has to be the one with their hands up, like, hey, I don't know why. You're just ugly. All right, so that is the end. Have a good day, and I will see you guys in a couple weeks.